Hello and welcome to Math 10C Prep Lesson 1 of our current quarantine. We're only supposed to be doing this for 2 days, so let's hope that that's true. And I see some of your beautiful faces in about 48 hours on Wednesday. That'd be nice. Today, what we're going to do is we're going to do some word problems on our radicals unit and our exponents unit. This will be the last lesson that we do. So that means the next couple of days we'll probably have a little assignment, some practice time, then we'll probably have a quiz in there and a test to see where we are at, and then we'll start off our next unit. Awesome. To start things off, let's answer a question. What is a radical? Because last week when I left you for the weekend, we were talking about radicals and what is a radical, the parts of a radical, the names of a radical, and stuff like that. So a radical is anything that has this symbol. That's called a radical sign. Radicals have that sign and then three parts around it. The first part is whatever goes underneath the radical. I'm just going to put the letter A right now to represent a number under there. We had a name for that thing. That name was the radicand. Awesome. The next thing that we had a little tiny number, and it went on like the arm of the radical sign. So usually there's a little tiny number right about here. I'm going to put the letter B to represent it. We called that thing the index. It equals 2 if not there. So if it's a blank radical, then it would be the number 2. And the third thing that we had to talk about when it came to radicals was if there's a big number outside of the radical like that, that thing is our coefficient. And what that coefficient is it's multiplying by our radical. So we have the letter C multiplied by our radical of the B root of A. That should all be review. Those terms and those names, I use them a lot. You're going to use them a lot next semester, especially if you're in my class. I try to always use the proper terminology. Sometimes we forget, but we try our best to. Then, after we learned about radicals, we started simplifying radicals. So to simplify a radical, typically it meant to change from entire. So an entire radical to mixed radical. Typically, that's what simplify meant. An entire radical, that means no coefficient. So a radical that doesn't have a coefficient, we call it an entire radical, and our goal was to change that from no coefficient to a mixed radical, which has a coefficient. And I said this skill was pretty essential for moving forward. In Math 10, it'll be a big topic, but in Math 20 and Math 30, essentially we simplify radicals all the time, especially if you're hoping to ever go -1. We simplify radicals pretty much every lesson, every day. It just keeps happening. So this is one of those essential skills that we need to learn moving forward. Let's practice it. So let's look at these 6 radicals right here. We're going to simplify them. That means we're going to change these radicals into radicals that have coefficients. To be able to do that, I have to have something called a perfect squares chart. So if you look at these numbers I've written here on the right-hand side in red, these numbers right here. Ooh, there we go. Those are my perfect square numbers. So the number 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are perfect square numbers, meaning that if I square rooted them, I get a whole number. Where if I square root any other numbers, it doesn't actually work out. You could continue to build that chart if you wanted. Just go 11 squared, 12 squared, and see what they equal, and you would build that chart. I already put it down there for you, so you didn't have to watch me build it today. We need that chart to be able to do these questions. So question 1 is the square root of 75. And the way that we do that is we have to find the biggest number from our perfect square chart that divides into 75. If I look, for instance, 75 divided by 64, it doesn't work. It gives me a decimal. If I go 75 divided by 49, it doesn't work. It gives me decimal. 75 divided by 36 doesn't work. It gives me decimal. But if I do 75 divided by 25, it does work. And it equals 3. So what that means is that I could rewrite the square root of 75 to be the square root of 25 times the square root of 3. Now, I didn't just pick two random numbers that multiply to be 75. I picked a number from that chart, and that is important. You have to pick a number from your perfect square chart. The reason why is that because once you split this radical into two radicals, I can now calculate my perfect square radical to equal my new coefficient. So the square root of 25 equals 5. So I no longer write it as square root of 25, I just put 5. And then my square root 3 is still there. I don't calculate that one because when you do calculate it, it's a decimal, and we don't do decimals. So that would be my final answer. The square root of 25 converts to be 5 times the square root of 3. Cool. We'll do a couple more together, then you can try a couple on your own, and I'll write out the answers for you. So if you look at the square root of 28, my goal is to simplify that. So I need to find a biggest number that divides into 28. 25 does not. 26 does not. 9 does not. But 4 does divide into 28. So that means I can rewrite this as the square root of 4 times the square root of whatever that equals, 5, 6, 7. Wonderful. I then can calculate whichever one came from my perfect square chart. The square root of 4 equals 2. So the answer is 2 square root 7. And that is my simplified radical. Wonderful. If you look at number 5, so I'm going to zoom in a little bit here. The difference between number 5 and the other ones is the index. This thing has an index of 3. You'll notice all the other indexes are 2. Because these were index 2, we were looking at perfect square charts. When it's index 3, we need to look at a perfect cube chart. So that means we need to start cubing our first few numbers so that we can use a perfect cube. Perfect. There we go. So instead of looking for the biggest perfect square that goes into 80, we need to find the biggest cube that goes into 80. 64 does not work. 27 does not work. But 8 does work. So we would break this up to be the cube root of 8 times the cube root of 10. So because the index was a 3, my chart I look at and I reference has to be 3. The cube root of 8 equals 2, and then cube root 10. That would be my simplified radical. Cool. I want you to maybe pause this video and then try number 2, 4, and 6 right below and see if you can get the right answer. I will then write down the answers so you can see if you did it right or not. So go ahead, pause the video, try it on your own. Awesome. Hopefully you did that. Let's look at 162. The biggest perfect square that goes into 62 would have been 81. So this thing should have broken up to be the root 81 and root 2. The square root of 81 equals 9. So my answer should have been 9 root 2. Number 4. Biggest perfect square that goes into 99 would have been 9. And that would have been times root 11. Square root of 9 equals 3. Root 11 is still just root 11. And number 6, the biggest perfect square that goes into 30. So if you tried that, 30 does not divide by 25. It also does not divide by 16. It does not divide by 9. And it does not divide by 4. That means this thing is simplified. If nothing can divide into that radicand, then it already is in simplest form. It doesn't happen very often, but if you have a radicand that cannot be divided by a number on the chart, it is simplified. Awesome. That's simplifying radicals. We're going to take that concept now and we're going to apply it in to some word problems. So we're going to start off with triangles. Typically, there's always a triangle question because it leads to radicals most of the time. So this one says find the missing side. I have this nice little triangle right here. I have to find this missing side over there. To do that, we're going to use Pythagorean theorem. Pythagorean theorem says a squared plus b squared should equal c squared. And on a triangle, C is always your hypotenuse, which is your longest side, and A and B are the other legs. So for us, this would be 4 squared plus 6 squared equals C squared. So I'm going to use this Pythagorean theorem, which I think you guys have been doing for a couple of years. You would have done it in Math 9, and you would have done it in Math 8, maybe even Math 7, depending on who your teacher was. So I'm going to use Pythagorean theorem. I have 4 squared plus 6 squared equals c squared. 4 squared is 16. 6 squared is 36 equals c squared. 16 plus 36 is going to be 52 equals c squared. And the last step of Pythagorean theorem that people always forget is that you need to square root both sides so that square root and that squared will kind of cancel and go away. So that you get this. You get that side length is the square root of 52. Now, before this year, you would have either left that as your answer or you would have calculated it and written the decimal. But now, we don't want to do that because rounding isn't an exact answer. And moving forward, we always want exact answers. So we need to leave our solution as the square root of 52. But the last step will always check to see if you can simplify this. So I'm going to take the root 52 and I'm going to try to simplify it. If I do 52 and I divide it by 49, it doesn't work. If I do 52 divided by 36, it doesn't work. 52 divided by 25 doesn't work. 52 divided by 16 doesn't work. 52 divided by 9 doesn't work. 52 divided by 4 does work. So I can rewrite this 52 to be the square root of 4 times the square root of 13. Then I can calculate the square root of 4 to be 2, and the root 13 will stay as root 13. Therefore, that missing side length is 2 root 13. That is the only thing that's going to be new to you when it comes to Pythagorean theorem, is we are now going to have to do that and calculate those simplified radicals as our final step. Awesome. Hopefully that's not too bad. Let's try one more together. The difference with this one compared to the other one to the left is that when you go to do your Pythagorean theorem, you're going to notice, oh, I actually do know my C value. I do know my A value, but I don't know one of my legs, which I'm going to call my B value. This means when I use Pythagorean theorem, I'm going to have to rearrange it so that it's now C squared minus A squared equals B squared. So instead of doing plus and adding, I'm going to do subtraction. I'm going to calculate the difference between those two side lengths. So if we throw those in, it's going to be 11 squared minus 2 squared equals B squared. That's 121 minus 4 equals B squared. That's going to give me 117 equals B squared. Then we need to square root both sides to get rid of that square, to find that that missing side is the square root of 117. Now, if possible, we need to reduce that radical. We need to simplify it. So you're going to take your calculator and you're going to start dividing it by things. You're going to go 117 divided by 100. And you're going to work your way down until eventually you get to 117 divided by 9, which would give you 9 and 13. The square root of 9 equals 3, giving me my final answer of 3 times root 13 equals b. Awesome. So that's Pythagorean theorem leading us to a radical, which we then have to simplify. All right, 2 more questions to do together. If we look over here at question 3, question 3 and question 4, we got a couple tricks here. So this one says, if a square has an area of 98 centimeters squared, determine the exact measurement of the square's length. So I have a square. Let's draw it. That square has an area of 98 centimeters squared. 98 centimeters squared. Perfect. They want us to find, so it says determine, that means find, the square's side length. Okay, so if I'm looking at this thing, I'm looking for the side length. I'm just going to call that L. Now, because it's a square, that is important here, I know that all the lengths are actually the same. Which means when they calculated area, what they did was they did length times width, but because it's a square, it's actually the same. It's length times length. That means their area was actually just their length squared, right? Because length times length is length squared. If they want me to calculate the length of something, then I would have to square root the area to get length by itself. This leads us to a new little formula, which is that you have the square root of your area. It will equal your side length. So for this question, our answer will be the square root of 98 equals our length. Which is a good answer, like that's fine and dandy, but because we are in this radicals unit, we know that we need to simplify that solution. So the square root of 98 is right, but it's not 100% correct because we haven't reduced it, we haven't simplified it. So I need to simplify that thing. The square root of 98 will break up to be the square root of 49 times the square root of 2. If you put that in your calculator, you should then get 7 root 2 is your length. You will see questions like that on your test. This formula, the square root of area equals length, is going to be important for you moving forward. Fantastic. The 4th question says, if a cube has a volume of 750 meters cubed, determine the side length of that cube. Okay, so I got a cube. A cube is a square box, right? So if we imagine we got a box like this. Well, that's the best box I can do. So, don't hate on me too much. I'll try to fix it a little bit. There we go. That's about as good as it's going to get. And they've told me that this cube has a volume of 750 meters cubed. The volume is what would fill up that entire cube, right? For us, volume always equals the length times the width times the height. But in this case, because it's a cube, all those side lengths are the same. So I could essentially say that the volume equals the length times the length times the length. So essentially, for a cube, the volume equals the length cubed. Just like the question above, that means if I want to find the length, I would have had to square root the area. For this one, because it's a cube, I'm going to have to cube root the volume to get rid of that little cube over there. This gives me my cube root of V would equal L, gives me a new formula. My new formula is that if you do the cube root of volume, it will equal your length. Wonderful. That means for this question, if I want to find the length of this cube, I would do the cube root of 750. And just like the questions above, I need to simplify that. So I'm looking at my perfect cube chart. Remember, my perfect cube chart is the one I made right here. Right? So I'm looking for the biggest cube that divides into 750. You would find that the biggest cube is 125. When you divide it by 750 by 125, you will get 6. I can then calculate that cube root of 125 to be 5. The cube root 6 stays as the cube root 6. That means my length of the cube is 5 cube root 6. Perfect. Just like the question above, you are going to see something like this on a test or an assignment or somewhere. You will need to know this formula. It won't be given to you. So these two things are very important. Awesome. You go ahead, you pause the video, you try the next 4 questions on your own, and then I will show you the steps to the work so you can also check your work and see if you did it right. Fantastic. Hopefully you paused the video and you tried your best. For this question, I'll go through it real quick. This is Pythagorean Theorem. I have my 2 sides. I'm going to call that side A, that side B. If you called them the other, if you called 3B and 6A, that's fine. But X has to be C because it's the hypotenuse. So for us, that means this is 3 squared plus 6 squared equals X squared. That's 9 plus 36 equals X squared. That's 45 equals X squared. You then square root both sides to get the square root of 45 equals X. You simplify that to be root 9, root 5 equals X, which is 3 root 5. That was your missing side length. Again, hopefully you paused the video, you tried that on your own, and you did the best you could. Awesome. Number 2. I'm going to go through this one quick so you can check your work. So if I'm looking at number 2, this time I know my C value. I have 5 over there, which I'm going to call A, and I'm looking for B, or my other leg over there. Because I know C, I need to do 15 squared minus 5 squared to get B squared, which is X. You put that in your calculator, 15 squared equals 225, minus 5 squared, which equals 25. You subtract those from each other, you get 200 equals X squared. Your last step is to square root. And I am now done Pythagorean theorem. I have the square root of 200 equals X. Again, we need to simplify that answer. So the square root of 200 is correct, but it's an entire radical. We always try to simplify our radicals in our final answers. You should have found that that will turn into 100 times the square root of 2. The square root of 100 is 10. So 10 root 2 equals X. Awesome. Number 3. This says the square has an area of 180. Determine the side length. We know that the square root of an area equals the length. Therefore, the square root of 180 should equal our length. 180 does need to be simplified. If you go and you divide a few times, you should figure out eventually that 36 goes into 180. So I have the square root of 36, the square root of 5. That means it's 6 root 5. Awesome. Number 4. This one's talking about the volume. We know that you need to cube root your volume to get your side length. So we're going to have to cube root our volume of 192 to find our length. Remember, you're using your perfect cube chart now, so not your perfect square chart. You should find that 192 can divide by 64, which would give you the cube root of 64 and the cube root of 3. make sure you're doing cube roots, right? The index has to be 3. When you do the cube root of 64, it equals 4. If you did the square root of 64, you would have got 8, which is not correct because we're doing cube roots. Our index is a 3. So our final answer would be 4, cube root 3. Fantastic. I hope you were just thrilled through this whole video. And I put on a show today. You weren't here to see it, unfortunately, because there were some great things going on in this classroom that you missed. But maybe in the future, you'll be able to come back and sit in these nice hard green desks that I know you probably missed so much. Take care of yourselves. You can practice on the practice sheet now. Shoot me an email if you need help with whatever's going on in life, whether it's math or something else. Just let me know. All right, take care of yourselves.